Okay, welcome to Tensor Calculus Problem of the Day, posted on 7/22. Okay, today we're going to take a look at the Levi-Civita permutation tensor, and it's given as this. Okay, and here are the rules. So if IJK is called an even permutation, you get a positive one. If it's an odd permutation, you get a negative one. And if any of the indexes repeat, you get 0. Okay, so we're going to use the coordinates to do this, which means that the covariant tensor is the same as the contravariant the tensor. All right, here's an example, and we're going to do a couple. All right, so I've got the number 1, 2, 3 IJK, right? So if I swap 1 with 2, so I put 1 here, I get 2, 1, 3. So that's just one move. It's odd. That means it's negative. If I change 1 with 3, so I go 1, 2, that's an even number, so I get a positive. If I replace 1 with 2 to get 2, 2, 3, these are all 0. Any repeated index are all 0. Now here's the way I like to do this. It's much easier visually for me. Is that if you go in a counterclockwise direction, 1, 2, 3, 2, 3, 1, or 3, 1, 2 is positive. If you go in a clockwise rotation, 1, 3, 2, 3, 2, 1, or 2, 1, 3, it's negative. Okay? So, the part A of this, we're going to do it old school first. Derive the cross product of the following two vectors using conventional definition, right? And we've all done this before. So what is A cross B? Just do it the way you learned. Part B, perform the same cross product using this Levi-Civita permutation tensor, okay? Now, immediately you're going to say, whoa, you've got covector components here. Remember, this is Cartesian coordinate frame. The covector component is the same as the vector component. They're equal, right? That's why we can get away with this notation. But it's still a proper tensor equation. It's just that in any other coordinate of the system, this would not be true, right? You would have to make allowances for that. Okay? So perform the cross product using this under these rules we just went through right there. Part C, another way to do a cross product. Calculate the same cross product using the wedge product. Okay, and here are the only rules you need. So we're going to do A wedge B. The rules are a vector wedge with itself is equal to 0. And A wedge B is equal to minus B wedge A. Those are actually the only rules you need, except how to deal with the basis vectors. But we'll get to that during the solution. Okay, so I'll post the answer tomorrow. All right, see you later.